Okay. Now here, irrational numbers, we have already just recognizing like root 2, like all these root numbers, huh? Root 5. Not only square root, you can have a cube root of 2, okay, fifth root of 3, and so on. We are able to recognize all these numbers as irrational numbers, right? Let us know about more about these numbers. More about these numbers. So now let me have a complete form nth root of a. Okay, this we call it as a radical. Radical or a surd. We'll call this as a radical. Now this n is known as order of the radical. A is known as radicand. Are you writing? What are you saying? Right. A is known as radicand. Now this symbol is there now. This symbol we call it as a radical sign. You understand? Radical sign. Only the symbol is there. The symbol we call it as a radical sign. Now, the exponential form also we can write for this. Exponential form. What is the exponential form? A whole to the power of 1 by n. Okay, this is the general representation of a root number. This root symbol, no? This root symbol we call it as a radical sign. Now, if you are writing n, in the place of n, suppose if you want to write 3, cube root of 5, for example, is there. So now in this, what is the order? This is a surd. What is the order of this surd? 3. Whatever the number is there in this corner, no? That is the order. How much is that number? 3. So order of this surd is 3. Then what is the radicand? 5. What is the sign, radical sign? Cube root. Okay. What is the exponential form? 5 whole to the power of 1 upon 3. Suppose if you are having only, there is no number, root 5 is there, for example, no number in the corner. So then what will be the order here? 2. If you don't write any number, then the order is 2. For 2, no need to write anything in the corner. And what is the radicand here? 5. Whatever under root, that is, we call it as a, what is the sign here? Square root. For square root, we won't write anything. And what is the exponential form here? 5 whole to the power of half. Half is different, square is different. 5 whole to the power of half. So this is about the symbol of root. Okay, these things we call them as a radicals. Now, for example, I will extend this little more. Nth root of a to the power of m, for example. That means the radicand is also having a power m. So then how do you write this as a exponential form? M by n. That means this power should be above and n should be the down. Always the order should be under the power. Okay. So here, for example, cube root of a square is there. Then what are you going to write? A to the power of 2 by 3. Right? Na? For example, you have fifth root of x to the power of 15 is there, for example. What are you going to write here? X to the power of 15 upon 5. So, which is equal to x to the power of 3. For example, let me write sixth root of a to the power of 10. So, what you have to write? A 10 upon 6. So, that means radicand also should have a power and order of the radicand. This is about, we call this as a surds, because this notation numbers we call it as a surd. So this is a surd, radical or a surd. You understand? Now, irrational number of this type we are dealing now. Okay? Have you copied? You have to copy along with me. Okay. Let me go to another question. Huh? I cannot give you, you have to do both the things simultaneously. You have to listen and you have to copy. I will show this later. I am not rubbing this board whenever I want, I can show. I am not rubbing it. Huh? I have taken a new board. Now let us understand about the surds. Okay. Surds are divided into two types. One is pure surds, the other one is mixed surds. Pure surds and mixed surds, two types. What are pure surds? If I give you examples now, then you will understand it. Root 3 is pure surd. 5 into root 3 is mixed surd. What is the difference between these two? It has no coefficient. It is just root 3. But in mixed surd, what is there? A coefficient is there, 5. 5 is not a surd, it is a rational number. So it is a rational number and a surd together. It is only irrational number. That means a surd. So pure surd is only this radical will be there, no coefficient. Whereas mixed surd will be there. Now you can interchange this. You can interchange. For example, root 12 is there. Root 12 is not simple because root 12 we can write 4 into 3. Am I right? Why I am writing 4? It is a square root now. We know the square root of 4. Square root of 4 is how much? 2. Okay. So that means I can write square root of 4 into square root of 3. So square root of 4 is 2 and 3. So that means some surds can be converted to mixed surds. Some, not all. For example, root 3 is there. Root 3 is pure. You cannot convert into mixed surd. Root 12 is there. You can convert to mixed surd. Mixed surd means a rational number also should be there. Let me give you another question. I will come here. 4 into square root of 5, for example. This is mixed surd. How to do this here? How to? I want to send this 4 also into the square root. How it will come? 4 square into 5. So when 4 goes into it, it will become 4 square. So then how much is this? 4 square is 16. 16 into 5 is 80. You understood or not? So that means they are interchangeable. Same way you can take 2 into cube root of 5 is there, for example. How are you going to send this 2 inside? You write cube root. This 2 should be go inside now. It will become 2 cube. If it is square root, square. If it is cube root, cube. You understood? And this is, so then how much? 2 cube is 8. 8 into 5 is 40. Cube root of 40. Let me give another problem also. Another problem. I am doing it mixed surd to pure surd. I am doing some problems. Huh? Now 4 into 4th root of 2. How are you going to do this? How do you send this 4 inside the root? Ah, 4th root won't change. This 4 is going inside, that means it is equal to 4 to the power of 4 into, already 2 is there now? That 2. So how much it will become? It is 4 to the power of 4 is 64. 64 into 2 is 128. How I got 64? Are you copying? Copy continuously. Each one is a problem. 2 into 5 to the power of, for example, 3. How to send this 2 inside? Ah, fifth root of? Ah?
2 raised to the power 5.
Yes, 2 raised to the power of 5. This 2 is going inside now. So 2 will have power of 5 into 3. Whatever the number is there now, that number should be there. So then how much it will become? 2 to the power of 5 is equal to 32. So 32 into 3. So it is equal to fifth root of 96. You understood? So that means when you want to convert any mixed surd, you can do like this. Whenever you want, you can do like this. Okay? Now I will be giving you some questions. You do it. Shall I open a new board? Do the following. Change into pure surds. Okay? I'm giving you some examples. 2 into square root of 10. 4 into cube root of 2. 5 into square root of 3. A into cube root of B. Okay? How much is the answer? Square root of 2 square into 10, which is equal to square root of 40. So this is how much? Square root of, sorry, cube root of 4 cube into 2, cube root of 64 into 2, cube root of 128. So this is how much? Square root 5 square into 3, 75. So this one, cube root. You have to write exactly in the corner, that V. Huh? You should not write outside. If you write outside, it will become coefficient. So a to the power of 3 into b. So cube root of a cube b. Okay. So this is a very very important. Now let us do from the other area also. Other area. What is the other area? Change, convert, mix pure surds into mixed surds. Example, square root of 8 is there. You have to write it in the product of prime numbers. Otherwise, it's 2, 4, 2, 2 like this. So then how much it is equal to? 2 into 2 into 2. Because it is square root now. For every two numbers, one number will come out of the roots number. For example, I'll do one more question. That is 32 is there. So 32 is there. Then how much it will become? 32 right here. 2 into 16, 2 into 8, 2 into 4, 2 into 2. So square root of how many twos? 5 twos. No? For every, because square root, no? For every two numbers, one number will come out. So one number will come here, one number. Only single 2 is left in the square root. So it is equal to 4 root of 2. I'll give you one more question. Suppose cube root of 16 is there. So 16, you have to put it in the, like this, 2, 8, okay, 2, 4, 2, 2. So cube root of how much? 2 into 2 into 2 into 2. So then cube root, for every three numbers, one number will come out. So three numbers, one number will come out, cube root of 2. You understand? Fourth root means for every four same numbers, one number will come out. Okay? Copy this question. Product of prime factors. So how are you going to write here? 27. 3 again. How many times? 9. 3. 3. So cube root of 3 into 3 into 3 into 3. So it is cube root now. For every three numbers, one number will come out of the group, square root. Let me do one more question. 40 is there, for example. Square root of 40. 40, what you have to do? You can write in the product of a prime factor. This is one way. So then how much it will become? 2 into 2 into 2 into 5. It is square root now. Only two numbers will come out. So two numbers ka one number only will come out. How much? 2 into 5? 10. Okay. So I'll be doing one more question. Square root of 405. Otherwise, fourth root I will write. Fourth root of 405. 5 table you can take. 3 table you can take. 3 table you can take again. So then how much? It is equal to fourth root of 5 into 3 into 3 into 3 into 3. Now what to do? What to do? Fourth root is there. But every 4 numbers, one number will come out of the root. Fourth root itself. It is 3. 3 into fourth root of 5. Right. Okay. You understood? It's very, very important. This is the basic. This basic is not given properly in the textbook. He has given directly the problems. In NCRT, he gave directly the problems. It will not give you any clear understanding. Okay. Now this chapter you are going to do it again even in the 11th class. So you need some foundation. This comes under foundation. Okay, basics. I'll be giving you some questions of this model right now. Okay, only 4 questions I'll give you. You try to do it. Change into mixed surds. Change into mixed surds. Then how much it will become? First question. Square root of 120. Second question. Cube root of 250. Third question. Fourth root of 48. Fifth root of 128. Shall start doing these questions. Square root of
30.
2 square root of
30.
okay. This one 5 cube root of
2.
yes, right. Fourth root of yes, right. Fifth root of
4.
Yes, this is also right. Hmm? So each question carries 1 mark. If you get all the 5 questions wrong, you can write 5 out of 5. Okay. Now let us see physics also. There is no question in the NCRT. Okay. I'll be teaching chemistry also, physics, chemistry, and also biology. Biology, Revati madam will teach you. Okay, physics, chemistry, I'll be teaching you. So, yesterday I was teaching you distance, speed, time, average speed, uh, and also taught displacement, or also task displacement. So here you have a task that distance and displacement. What is the difference between distance and displacement? Distance and displacement. Can anybody say what is the distance? What is the difference between distance and displacement? Hmm. Hmm. Hmm.
In distance, there is no fixed direction. In displacement, there is a fixed direction.
Very simple. Very good. Distance have no direction, and distance has no direction, and displacement has a direction. That's it. And distance is a scalar quantity, and this is a vector quantity. You can write two difference or one difference. Usually it will be asked as a 1 mark question. So what distinguish between distance and displacement? So distance is a scalar quantity, displacement is a vector quantity. This is the usual definition or difference between distance and displacement. Again, I will explain you what is the displacement. A body moves from A, okay, changes its position by moving like this to B. Okay, the change of position from A to B, it goes like this and it came and it traveled here, right? So the distance between the initial position and the final position is equal to the displacement of the body. The displacement of the body. So initially the body is at A. The object is at A. After some time, what happened? It traveled in this direction, in this path, and came to the final. So finally, the object is at B. So now, whatever we travel now, we call it as this is a displacement distance, and this we call it as a displacement. So it is in this direction. It is in this direction. So the body displaced from initial position to the final position, and in the direction of the B. In the direction of the B. So this AB, the length of AB is known as displacement. The length of AB is known as displacement of the body. So what is the direction? It is in the direction of B. Because it is a length, its unit also the unit like a distance. Okay, distance unit is meters and displacement unit is also meters. So in the examination, suppose if it is asked, explain the distance and the displacement with an example. You can write the same. You can write the same. You can have this. So now whatever the travel object travel from A to B in the path, that we call it as a distance. Okay, and it is definitely more than the displacement. Now here, suppose if you want to travel the displacement with a speed, suppose A to B directly you wanted to come, then we call it as a velocity. So velocity is nothing but has a direction. It goes in the direction of the displacement, isn't it? Velocity, speed is related to the distance. Velocity is related to the displacement. Okay. So velocity is related to the displacement. If if the speed has a direction, if the speed has a direction, then we call that speed as a velocity. So here again two quantities are there, speed and velocity. Both are same only, but the thing is speed has no direction and velocity has a direction. Or you can call it as speed as a scalar quantity and velocity is a vector quantity. And what is the unit of speed? Meters per second. Velocity also meters per second in SI system of unit. So then, what is the velocity definition? Displacement by time. I am giving you in short the displacement by time. And what is speed? Distance by time. You understood the difference between speed and the displacement? Speed, when it comes to speed, we use the distance. When it comes to the velocity, we use a displacement. So then velocity has a direction. As the displacement is having direction, velocity is also having direction. Okay. Suppose here you take the same example. The body is moving from A to B in this path. In this path, we call it as a distance. Okay, the same body traveling from A to B in this direction. Okay, this is also having speed, and in the other case also having the speed. In both the cases, it is having speed. But if you are having directed speed, like in towards the displacement, if the speed is there, then we call it as a velocity. And here we call it as a speed. It has no direction. You understood? So the difference between speed and velocity is that. So speed is equal to distance by time and velocity is equal to displacement by time. So in the other words, we can define a velocity like that. It is the rate of change of velocity. Rate means by time. Whenever you are using rate means by time. So rate of change of velocity. Sorry, I'm extremely sorry. It is not velocity. Rate of change of displacement. Rate of change of displacement is velocity. So what is the unit of velocity? Meters per second in SI system. Centimeters per second in CGS system. And feet per second in FPS system. And general unit is also there. Kilometers per hour also is there. Okay.